Hello everyone, my name is Varad Lomte. Today, the topic of my presentation is cogeneration and trigeneration system. So, here is a diagram of cogeneration and trigeneration. We can see it. So, what is cogeneration? Here is a diagram of cogeneration. So, cogeneration is a very efficient technology to generate electricity and heat. It is also called combined heat and power as cogeneration produces heat and electricity simultaneously. Cogeneration supplies currently 11% of electricity and 50% of heat in Europe. So, working of cogeneration. A cogeneration plant is like CHP in the sense that it also generates electricity and produces heat. Cogen technology differs, however, the CHP in that it produces electricity from a simple cycle gas turbine. The gas turbine exhaust energy is then used to produce steam. Cogeneration is a way of generating both thermal and electricity. In conventional thermal power plants, outlet steam needs to be cooled before pumping it to the boiler again. Cogeneration allows for using the waste heat and thus enhancing the overall system efficiency. So, need of cogeneration. Cogeneration reduces air emissions of particular matter, nitrous oxide, sulfur dioxide, mercury and carbon dioxide, which would otherwise lead to greenhouse effect. It reduces cost of production and improve productivity. Cogeneration system helps to save water consumption and water cost. Thermal power plants are a major source of electricity supply in India. The conventional method of power presentation and supply to the customer is wasteful in the sense that only about a third primary energy fed into the power plant is actually made available to user in the form of electricity. In conventional power plant, efficiency is only 35% and remaining 65% of heat energy is lost. The major source of loss of convection process is heat rejected to the surrounding water or air due to internal constraints of the different thermodynamic cycles employed in power generation. Also, further losses around 10 to 15% are associated with the transmission and distribution of electricity in the electric grid. So, advantages of cogeneration. The first advantages of cogeneration is enhancing operational efficiency to lower overhead costs. Second advantage is reducing energy waste, thereby increasing energy efficiency. Third advantage is offering greater energy independence by moving a portion of the load of the grid. Fourth advantage is allowing companies to replace against infrastructure. So we have to move on the next slide, that is disadvantages of cogeneration. It requires space for the CHP energy center. Second, it requires large diameter heavily insulated metal piping for the hot water gases or network. Third, it suffers heat losses to the ground. Fourth and last one is setup cost to administer and run the central energy center over the whole life of the system. So we have to next study about the trigeneration. So what is trigeneration? Trigeneration or combined cooling, heat and power is the process by which some of the heat produced by a cogeneration plant is used to generate chilled water for air conditioning or refrigeration. An absorption chiller is linked to the combined heat and power to provide this. So Working of trigeneration. Trigeneration is the production of combined cooling, heat, and power from a single generator or process. The trigen system produces electricity and useful heat which is utilized for hot water, space heating, or steam production as well as energy efficient cooling. The principle of trigeneration is based on the generation of the heat energy, heat captured through burning waste, production of energy with generators, or heat generated through solar panels could be used to generate hot water through heat transfer equipment or cooled chilled water with absorption chillers. So, our next slide is need of trigeneration. The trigeneration system reduces the heat offtake from the heat exchanger station of the heating plant, reduces the cost of electricity needed for indoor air conditioning, and generates electricity for its own consumption. Trigeneration is a technique for producing three useful outputs, that is, electricity, heat, and cooling simultaneously from one or more energy inputs. Trigeneration is used to buildings such as hotels, hospitals, university with demands for heating, cooling, and electricity. Absorption refrigerations are the type of equipment most commonly used for the production of cooled from waste heat. The most common refrigerant absorbent pair is water lithium bromide with operating temperature of 75 to 90 degrees Celsius and producing cold water of air conditioners between 12 and 7 degrees Celsius. Absorption cooling is not a widely used technology. It also produces cold through residual heat, although it has disadvantage of low COP, that is 0.3 to 0.5, and low cooling power per unit volume and weight. Our next slide is advantages of trigeneration. On-site high-efficiency production of electricity and heat reuse existing cogeneration to reduce electricity consumption, reduce emissions and reduce costs substantially, reduce site CO2 emissions by up to 60 degrees 50% over business as usual by generating electricity on site using natural gas. So our second advantage is, in addition to reducing carbon emissions and contributing to sustainable goals, cogeneration offers many other benefits, including enhancing operational efficiency to lower overhead costs, reducing energy waste, thereby increasing energy efficiency. So, disadvantages of trigeneration. It also produces cold through residual heat, although it has the disadvantage of low COP, that is 0.3 to 0.5, and low cooling power per unit volume and weight. Trigeneration configurations can be classified into basic and advanced. So our last one is difference between cogeneration and trigeneration. Cogeneration and trigeneration refers to installation that use an engine that burns natural gas to generate electricity on site. Cogeneration produces electricity and heating, whereas trigeneration produces electricity, heating, and cooling. Cogeneration and trigeneration refers to installation that use an engine that burns natural gas to generate electricity on site. The waste heat retained and used for heating or converted to chilled water for cooling through absorption chillers. Cogeneration produces electricity and heating, whereas trigeneration produces electricity, heating, and cooling. So thank you everyone for hearing me very silently.